Hello, everyone. Thanks for tuning in for another episode of SQUPCAST. I am Adam from Squared Up, as always, and today I'm joined by Matthew from our engineering team. Hey, Matthew.
Hey, how's it going?
Very good, thanks. First time having a whole episode dedicated just to yourself. You appeared last week, 2 weeks ago rather, in our Mid-Year Madness episode. So nice to have you on in all your glory, just the two of us.
Yes, I mean, I do have some beef for you from the last episode, though. So I'm just going to, in true podcast fashion, I'm going to start off with some beef.
Okay.
My beef is, on the last episode, you were introducing various members of Squared Up, and you were like, oh, here's my esteemed colleague from engineering. Here's my esteemed colleague from... And then you get to me and you're like, oh, here's Matthew.
Okay.
And the next person comes on, hey, here's my esteemed colleague. Am I not esteemed enough for you,
Adam? I thought it went without saying. Maybe. Right. Well, anyway, we've got a lot to talk about, so let's get into it. We can deal with our beef offline on Slack later. But so today's topic, relayed from behind enemy lines. The enemy lines we're talking about in this context are basically, let's say, firewalls, right? We're talking about data that we can't naturally get to from our SaaS platform and how we make that work for people. So maybe it's worth just starting out. I'm just looking at the list of people who are already sort of watching live. There's a lot of existing customers who use our dashboard server product, running data centers with System Center in them and all sorts of juicy enterprise IT data available. I would assume those people aren't just going to say like whitelist the internet so Squared Up Cloud can get to my data. So yeah, tell us a little bit about the relay and sort of what else it can do, why we built it.
Yeah, sure. So the relay was built fundamentally with the idea that we would need to be able to access, at some point in showing your dashboards, private data. You can think of this classically as the on-premise sort of thing. I have a data center that my organization owns and operates that's obviously segmented off from the rest of the internet. And I've got some valuable data in there that I can get insights from if I can get it into Squared Up Cloud. But as you see, I don't want to open up firewall ports to let this sort of thing in. But it doesn't have to be a data center. I really want to sort of stress that with this. If we're talking, it's any private network really. So it can be, Azure or AWS virtual private networks. It can be private in the sense that it's within a Kubernetes cluster. And that is how you've sort of carved off the internals of your app, say a Prometheus database, from the rest of the network. Even if it is your own internal network, you've still sort of carved that way. You need to be able to get data out of there in order to get insights. So the whole point with the relay was that we'd be able to place that behind that corporate or edge firewall, and then it would establish an outbound connection and dial home, and then act as a way of mediating traffic between data requests that we have coming from Squared Up Cloud and your own private data. So yeah, while it's primarily designed to access sort of on-prem, it can be used for a variety of scenarios. And like I say, like it's not just so the old school things you think of, like a SQL database sat in our data center. I know one of the scenarios that you use it for quite extensively is talking to SQL instances hosted in Azure, where, as you say, your security options there are somewhat limited. You don't want to whitelist the entire internet. So it's actually much easier to say, well, I can have a particular IP address that I know traffic's going to come from. That's whitelisted, and then that can be used to talk to it. So it's any time you have private data that like a cloud provider or the cloud vendor themselves would not have access to. Again, if you think about a Kubernetes cluster, it could be running in AWS in their managed services or bare metal on VMs if you want to configure it that way. They've got access to they have public APIs let you get access to data about how your setup is running, but they have no access into any of your data because it's being held privately. You have those keys and access, and that's what the relay is designed to get into, basically.
So I guess the two sort of key big benefits there are, one, you don't want to allow inbound traffic, and currently with our app, we don't limit our outbound requests from our platform to specific IP addresses, right? We couldn't give you the IP address for Squared Up Cloud. We'd have to give you the list of 14,000 possible IP addresses that AWS happens to use with the services we use. And obviously no one's going to want to spend their time doing that. No. So being able to sort of drop an agent into a network, wherever that may be, on-prem or in the cloud or whatever the service is, dropping it behind some enemy line. Let's just go back to the title there. And then that other case is, it's more about being able to know the IP that the request is coming from. So like you mentioned Azure SQL there, again, like you don't want to just put 0000 as your range for allowed traffic. In that, you want a known IP address, and chances are you probably already have that set up from your data center or from your office network or from some other Azure network, that kind of stuff. So in most cases, people aren't going to be sort of deploying any big brand new architectural decisions here. It's just going to be drop it on somewhere that you already have, if not a dedicated machine to do it.
Yeah, exactly. We've designed the thing to be as lightweight as possible. So the choice is yours, whether you want to put it on, a dedicated, like this is the squared up agent machine and it talks to 10, 20 different services and servers, or if you want to be like, well, all I want to do is click this thing to SCOM right now. I've got a SCOM management server. I'll just put it on there.
Yeah.
And it talks directly to the thing locally. So that's kind of the flexibility, which is a recurring theme with the agent, is yours to choose how you want to deploy it.
Yeah. Okay, well, we've got a little series of show and tell diagrams to work through to make a few of these use cases. But just before we bring that up, the deployment options we have now are basically Windows or a Linux container, right? That's the two current sort of ways that we have for deploying it. So you can either install it on a Windows server or drop it into Docker or Azure container instances or, that kind of stuff.
Yeah, you could, exactly. It works on all the public cloud providers, so you can put it into AWS or Azure running as just a container, which is a really nice way of being very hands-off about it. Like, I don't care about this software, just make it run. It's really just here as a way of me proxying some traffic. Or you can go the full way into having like a Windows VM dedicated somewhere where you've tweaked the settings and you know exactly what it's got access to. And again, like, you can be as prescriptive as you want with the firewall around that box. If you want to treat that as like, well, I'm not really sure about squared up, you can firewall that thing off as much as you want and really lock down permissions, because it's a piece of software you control again now. And it is a small piece of software. It's bundled with all of its own dependencies. So regardless of whether you choose the Windows or containerized version of it, there's no other prerequisites to install. It is just a bunch of binaries, and it manages all of that itself. And we intentionally made it as well as hands-off in terms of your management as possible. So what we didn't want to do was every time you configure a new plugin in Squared Up Cloud or change some settings there, you have to go and do something to the agent, like managing it in two different places. So the idea is that you basically set it up once and then you kind of forget about it. And the only time you ever upgrade it, and we'll see this later, is like when you get a notification that there's a new version available. And we don't, your plugin updates, so your data source updates, I should say, sorry, are not tied to agent version. So we can, in the background, be enhancing the data sources and putting further integrations and data streams and things in them, and you don't have to do anything to make that work. Likewise, when you set up and choose to enable a new integration, you don't have to go to the agent and then make it install like a connector or something like that. It does all that for you itself. So it's very hands off.
Yeah, nice. Okay, and just to speak to how lightweight it is, I run it at home on my Synology NAS in Docker, so that I can connect to my home VMware lab.
So that is like as thin as it gets, right? Like, that thing does not have a lot of resources, and it runs on it just fine. I mean, as I said, like I will be clear though, like your mileage may vary. If you start sending hundreds of thousands of requests through it a second, obviously it's going to start consuming a lot more resources. So
Cool. Okay. Well, let's jump into some fun diagrams. Let's bring this up sort of a bit bigger. So the case here is we've got Squared Up Cloud over on the left with 5 plugins. Just to caveat, I was thinking Prometheus when I put the Kubernetes logo in here at the bottom. So think Prometheus, don't think Kubernetes. I was thinking Prometheus in Kubernetes, to be fair.
Stuff everyone has, yeah.
Exactly. On the right, then we're sort of showing, say 3 physical locations running different services, and they all have access to, let's say, some private cloud service. Let's say it's Azure, right, where Prometheus is running. There's some certificate service running there, there's SQL running there, but they're all heavily restricted to only allow access from those 3 physical locations. So I guess that if we start sort of going through them sequentially, let's sort of talk about like how do we plug this into this? Like, what's the starting point?
So can I just get you to I think you've got there as well, like the got a product where you've got the relay sort of setting screen. Just I want to just define 2 quick terms, because we're about to use 2 proper nouns quite a lot here, which is agents and agent groups. It
Yep.
might be good just to level set on what those two things are in case you're not familiar with this in the product. Sorry to.
Yeah, no worries. There we go.
There we go. So yeah, the two parts of this whole paradigm basically is that you have an agent, which is the piece of software that is going to actually run your queries for your data sources, for your integrations. And then you have one or more agent groups as well. And agent groups are like a pool, basically. They are a way of you grouping together a bunch of agents and saying, these have similar network connectivity. They're in the same environment and they have similar permissions. And then when we've got a data source that wants to get some data, you have assigned that each data source instance that you've created. So when you put credentials in and say, oh yeah, this is where my vCenter environment is, or this is where my SCOM server is, or whatever, you've picked an agent group and said all the traffic that needs to be honored for this data source goes through this agent group. And then our system will pick one of the agents available, and it does load balancing in that agent group to handle that request. So what that means is if you've got a very simple network, and for whatever reason you decide that I'm kind of okay, I don't need to have 99% availability with Squared Up, one agent group, call it a day, done, everything's pointing at that one agent group, you're good. If you've got multiple data centers or multiple different levels of privileged environment, or you've got services have only been available in one location and your inter-network links between them aren't great, so you're not going to want to go, traffic goes from New York all the way across to Vancouver and then back again kind of thing to be able to service a request, you're probably going to want to create some agent groups. And there's no configuration to them. They are just literally a collection of agents, and agents can be in more than one agent group as well. But that is sort of the paradigm that you'll see when you try and create this stuff. So you need an agent and you need an agent group. That's the simple case, just those two. If you want to get fancy after that, or if your network topology means that you need to, that's when you're going to start creating multiples of these things. But I mean, if you've configured a lot of enterprise software, and this is an enterprise tier feature, you will be very used to this stuff. Lots of products have a pool or a group of some kind of workers. So it's a pretty common concept. I imagine you'll all be good with it. So yeah, now we define what an agent group is. Let's go back to the diagram. So yeah, let's imagine you've got SCOM. It's a pretty easy one. So you've got three different data centers, three different networks, I should say. They've all got a SCOM management group in. Those have got some kind of, in the case of SCOM, SQL, you're replicating that storage around. So you need to make sure that any plugin, the SCOM plugin, is able to get to the SCOM management servers. And it can hit any one of them that you like, but they're in different networks. And for HA, you want to say, well, look, when someone uses Squared Up and they want to get some insights on a problem, that problem could be at 2 a.m. I need it to work. It's no good to be down for maintenance right now or whatever else because someone's doing some patching in a different data center. So what we can do is we can create multiple agent groups. So we can install an agent on the management server or close to it in each network. Ideally, we're going to reuse these things, right? You don't need to have an agent for every single data source that you create. So here we've got one agent in each data center that is closely located to its management server, so it gets good response times when you're making queries. Those have to be deployed on Windows because some of our plugins, 2 of them, SCOM is one, require a Windows agent specifically. We'll talk a bit more about sort of the agent's platform and then what that means for agent groups in a bit. But the short of it is SCOM stuff has to run on Windows. Therefore, the agent also needs to be Windows as well to be able to talk to that SDK. So we can create an agent in each one. We don't actually, because they're pointing at the same management group, we don't actually care which one the traffic goes to as long as it's going to be highly available. So we can create one agent group, and then we can assign the SCOM plugin to that agent group and say, well, look, any traffic that goes to the SCOM servers, it can hit this agent group. And as long as one of them is up, we not only will it up, we'll also load balance the traffic that's going in there to try and spread it between these 3 servers. So now we have achieved a sort of a fault-tolerant way, a load balanced and fault-tolerant way of being able to talk to your SCOM environment as long as one of your management servers is up. And I think if all of your management servers are down, you might have bigger issues than oh no, my Square dashboards don't work. But that is sort of the canonical example of achieving that sort of scenario.
So the simple deployment here would just be an agent group with a single agent in one of those locations. You've got access to SCOM, and all the requests are going through that one route. But in this case here, you've already got SCOM distributed, so you're distributing the agents as well for the sort of same reason. And when you try and get some SCOM data in Squared Up, one of those three agents at random pretty much is going to serve that request.
Exactly. So if one of those management services is offline or unavailable, or the agent is offline or unavailable, in this now sort of more complicated topography, the dashboard will keep working. In the simple case, if it's turned off, it's just not going to respond, and you're going to get errors in your dashboard because we can't surface the data that you might need.
And crucially there, you mentioned in this case, the SCOM plugin requires the agent group to be Windows only. It's not that the group can have a mix of agents in and it will just pick Windows ones. The group has to be exclusively Windows agents.
And the UX will reinforce, the cloud product will reinforce that. So if you try and assign, if you assign an agent to an agent, Linux agent to an agent group that's got specific Windows plugins assigned to it, it will say, no, you can't do that because you're going to break this, because that Linux agent now will maybe, randomly, will start to receive queries it can't honor. In the same way that if you're in the SCOM, on the reverse, if you're in the SCOM plugin and you're configuring it and you're seeing the drop down will tell you, I don't have any agent groups of this platform type. I need you to create a Windows only agent group to be able to talk to this. But we'll show that again later on.
So you can't break it, basically. Nice.
You shouldn't be able to break it. No. There are a few ways you can do it, but you have to sort of maliciously try. So it's unlikely anyone would see that in reality.
So in this case, what we're basically demonstrating is that the agents don't need to be in the same networks. In this case, all we care about is that they're all Windows and that they're all in close proximity to the service that they're going to talk to, even if they're on completely different continents geographically. In this case, it just matters, quick response time and plenty of availability.
Yeah, exactly.
Okay, well, on to the next two then. They're in the same location. And I mean, we already have an agent there, right? So surely we can just say, just make a new, we could even just use this. Well, could we use the same agent group? Probably not, right? Because some of those agents don't have access to those services.
Yeah, exactly. So we can't, if we have a WAN link between all of this and all data centers can talk to each other globally, yes, we could, but the connection speed, your mileage may vary if it's trying to go all the way across the Atlantic or something to try and talk to data centers far away. So what would make the most sense here is to use an agent close to those services. Now, in the case here, we do have an agent in that data center already. And again, depending on our availability needs, that might be good enough. We might just say, the VMware and SolarWinds, those plugins are cross-platform. They work on any agent platform. So they'd be perfectly fine putting them through there. If, however, the volume of traffic is such that actually that box is going to start struggling a bit to handle that, or if we do have some HA concerns, again, you need that sort of, I want to use this thing to troubleshoot issues live, and potentially I'm doing that during maintenance or downtime or something else. I could put another agent, one or two, it's up to you really how many you put in there, into that data center, and then create an agent group specifically for that data center. So I can say, well, it doesn't matter what plugin it is, but it can go into this agent group and know that it's able to hit an agent that is inside that data center. We'd call this, the UI calls this a mixed agent group because it has a mixed platform. But as I said, of all of our plugins, only two of them are actually platform specific, which is the ODBC plugin and the SCOM plugin. The rest of them are all cross-platform. There's no difference between them. And there's even no, because again, we bundled all the dependencies, you don't have to configure your boxes, pre-configure them with requirements for the plugins. So there's literally no difference to you whether the plugin is running, for VMware is running on Windows or Linux. It works the same. It's all the same capabilities. It's a sort of black box, and we handle that for you. Here we create an agent group called Data Center 2, or whatever the data center is called, Paris, production. And then we can assign all our plugins that are based on that location to that agent group. And because as long as one of these three agents picks up, happy as Larry, right? The traffic's going to be load balanced between them, and we're going to have to talk to those services that are there.
So just, I mean, in the last case, we still made the point that you could just have your agent group with a single agent in one of your locations to access SCOM. In this case, we could just have an agent group with just that one existing Windows agent in it. But in this case, if that agent's offline, we lose access to all those data sources. And plus, if it's under high load, maybe there is benefit actually in being able to distribute it. So in this
The other
case,
reason you might want to do this here is permissions.
yeah,
So the agent runs requests as the service account is running under. So in the case of like SCOM uses Windows Auth. So that agent is configured as a domain, is running as a service account with access to SCOM. If you didn't want to have that same resource able to access other things like data center, you might run another agent as a different entity. And again, that's another reason to go ahead and do that there. Again, SCOM is the outlier plugin because it's also the only one we have that requires you to specifically run the agent as a certain user, because the agent currently does not support impersonation of Windows identities. So it needs you to run it as a domain user. The others don't. So in this case, like SolarWinds and VMware, you give the plugin depending on what it wants. Some of them want an access token, some of them want credentials, and we can run it as that. That's fine. But that is the other reason you might not want to do it. Your security team might be somewhat unhappy with the idea that like this one box is configured to talk to everything. And if there are sort of internal firewall or network restrictions, that's another reason why you might choose to have more than one agent there.
It's probably worth saying as well. I mean, we in our internal environment, our main production environment internally, we run multiple instances of the agent on one box for that reason, right? We want to give like an agent, one agent can talk to our SCOM environments. There's another agent just for running PowerShell scripts that are stored locally on disk. There are other instances set up just, as local Windows services that just make API calls to other things.
Exactly. So it's kind of, there's no reason why you can't run more than one agent. But again, they could be sat on the same box. You don't have to think, multiple VMs here now.
Yeah.
It supports side by side perfectly happily.
Yeah. So that Windows server running that Windows agent could also be running Docker desktop with those two Linux containers running in it. Yeah,
exactly. Or if you probably have an existing Kubernetes cluster in there anyway. Well, why not throw an agent into the pod? And have it running there.
Okay, cool. So we've had sort of a distributed app across 3 data centers. We're providing local redundancy by having those 3 deployed agents that have to be Windows in this case. For DC2's data sources, we want to keep that resilience of having multiple agents. They don't necessarily all have to be Windows, but in this case, we do want that benefit of them all being on the single site. But it's important data, so we don't want it to be offline as such. So three different instances just to keep it up and running. Okay, so in this last case then, these are cloud services. And like we sort of mentioned at the beginning, Azure SQL is a perfect example where you kind of want to know your source IP address for the traffic. And let's say in this case, all of these services already have Azure Firewall rules open that allow traffic from any data center within this corporate network, but not from the internet generally. So what's kind of the situation here? Wild West, free for all?
Yeah, pretty much. You don't, in this particular case, if you don't care about if all your internet connections are equal, you know what I mean, like you're paying the same in each data center, you might as well just create one agent group that's got everything in it. Again, if it's a cloud if it's a cloud technology like Azure SQL, it literally doesn't matter what platform it's running on. It's a hybrid, it's mixed, so it will work with anything you like. So to achieve that sort of maximum redundancy and load balancing, we might as well take the existing agents that we already have everywhere and just put them in that group and be like, okay, cool. Well, traffic can now go to any one of these that's available. As long as one of these listeners is available, we can hit the Azure Data SQL database and get data from it, which is quite nice. So we don't have to do this. Again, we could have maybe just said, oh, well, we're happy enough. The connection in data center 2 or the bottom one is actually the closest or fastest. Maybe we've in some cases, people specifically pay to have the data centers in the same region or county as cloud providers, knowing that they'll get that sort of better latency to their apps and to their data when it's being held in that sort of place. So maybe we'll just put it through those 2 agents at the bottom because that one is actually quite close to the region that we've selected. It's really sort of up to you how you do it. Yeah. So as I said, like, let's go on.
I was going to say, in this scenario, we've kind of just followed the rules we've already taken of sort of beefing up each site's resilience by adding those extra 2 containerized agents at the bottom. There would be no reason actually in this scenario why we couldn't just have put one of those agents straight into Azure, right? Straight into that cloud cluster.
Yes, exactly. That's probably the most sensible thing to do, right? In that sort of particular scenario, like why go to your data center and then go up to Azure? We just start in Azure in the first place. So you can definitely take that approach, and we've got a containers running, so both in AWS and in Azure as well, because we actually consume both services. We say, like, you want to connect Squared up to multiple different clouds. That's what customers do. That's what we do as well. So yeah, putting it in your virtual private network in the cloud natively is probably the most sensible thing to do. But you could also do that from your own data centers as well. If you have other similar kind of services, you've got there. Prometheus is a good example of that, right? You might have clusters all over the place, and you've got management boxes configured where you say, well, these existing servers are allowed to talk to these endpoints, but nothing else is. Same thing, just put them in. The traffic between your sites is good enough for your traffic between your networks, because there could be multiple different networks in the same building. This could be geographically separate locations. This could also be test, prod, and UAT, and they're firewalled off from each other. So you're just going to put those environments in, and because you want to get some insights into how your test environment is running, because if it's running really poorly after a deployment, that maybe means that when you put it to production, it's going to performance is similarly going to degrade. So however you need to sort of structure this, you can. I mean, this is a scary looking image, right? Like, what I just wanted to get some data out of SCOM, and now suddenly I've got all these different servers and things to manage. I want to be very clear. This is like the most complicated scenario where you're trying to get 5.9 availability, and you're heavily invested in Squared Up and its uptime. If you don't patch and take down servers on a regular basis, or just sort of you've got strong controls, and you already maintain for all of these services like SCOM high availability, if you're talking to a vCenter environment that is heavily load balanced and has all of these provisions in place to make sure that it's always available, you probably don't need to have multiple agents configured all over the place. It's probably fine. Likewise, if your container is running on Azure Container Instances, it's not going to experience downtime realistically. If someone goes into Azure and stops it, like it's going to stay running. That's the whole point of running it on their metal and in that way. So I do want to sort of emphasize that the most basic scenario of one agent group, or maybe one agent group, two agents, if you are concerned that someone's going to go and turn the box or turn the pod off, is what we find for most people in almost every environment. Like, I think you really would have to see some performance problems before you start scaling this out. I would encourage people not to overthink this and start out with this sort of model if you don't need it, especially because it's very easy to just bring a new agent online and add it to an agent group. We don't have to then reconfigure or restart a whole bunch of stuff. Scale it as you need it, is what I would say. Start out small. If you've only got one app in one data center, put one agent there, happy days, and add stuff as you go.
Yeah, and the Squared Up Cloud will sort of keep you right as well when you're, like you said, when you're adding those plugins. If you want to use the SCOM plugin, you must have a Windows only group. So why not start small, put the agent onto a SCOM management server, just as a single try. Just talking about actually sort of how traffic gets back out. The parts in this diagram that we've sort of got labeled up as SCOM DC2 global services. This is an Azure service that we use to sort of act as the bridge between our cloud platform and the agents running in people's networks, people's services, wherever that may be.
Yes.
All of the traffic from the agent point of view is outbound from a like a firewall point of view, right? You don't have to open inbound ports to allow this to work. It's WebSocket based. So the agent's basically listening to a queue for a request that it can serve. That's the sort of the high level how it works architecturally. The cloud platform puts a request in a queue, and an agent listening to the queue picks it up.
Exactly. Yeah, that's sort of the key point there. Like when you look at the docs, there's a couple of different firewall ports, or not. It's not ports. It's really more just make sure you can get outbound connections to these things. So the services there are like Azure, and that's the relay part of this. Is we are using Azure's services. So in terms of like security and trust and everything, like it is secure. It works. We are using that to be able to proxy that connection. So we use Azure for that, one of their services. And then you'll also see outbound traffic to SquaredUp's API, which is hosted in AWS, because we like more than one cloud provider here. And that is going to be used to download download data sources, download resources and things that the app needs to update. So the agent doesn't update itself. That is still on you and you can therefore wrap that in your appropriate change controls processes and testing and everything else. But the data sources, the integrations, will self-download from our API. That's why you've got those two different locations that you need to sort of make sure it can get to. But as Adam said, as long as it's outbound, which the vast majority of the time that is configured to be the case, which is why it kind of works quite nicely. It creates a WebSocket basically into Azure, and then it bidirectionally communicates through that WebSocket. So as long as that initial outbound connection is allowed and set up, then it just keeps listening. And should anything interrupt that connection, it will reconnect automatically and all that kind of stuff as well.
Yeah, nice. Okay, well, probably just worth calling out as well. I mentioned the sort of PowerShell plugin. There is an on-prem PowerShell plugin, and where that's somewhat different to some of these, to most of the other plugins. Most of the other plugins just work as you expect. You go into SolarWinds, you might want CPU, you pick the scope, you pick a world object. The PowerShell plugin lets you actually, you would sort of interact with the agent in a way, because you probably are putting scripts that you've already got, scripts you already use into a folder on disk.
Yeah.
And the plugin can then basically execute those scripts. So again, even in that case, all your scripts are sort of stored within your own boundary, running as your own service on your own machines, just outputting JSON data back through our platform.
Yeah, exactly. So you'll notice when you look through the app, through SquaredUp, that we have a lot of plugins, like say for Grafana, where there's Grafana and Grafana on-premise, and the two plugins are actually exactly the same. They have the same capabilities. Internally, we call them hybrid plugins. In engineering, that basically means we write it once, and then you get an on-premise and cloud version, and they behave identically. The PowerShell plugin is one of the exceptions. The reason for that is obviously in the cloud, when you just give us a random script, we run it. We're running it on a Lambda. The Lambda gets thrown away afterwards. You as a customer aren't so upset about the content of what's in that script, because it's not running in your data center. It has no permissions to your private data or to access anything. It's really only useful to sort of talk to public APIs and do things that we can't handle with our other plugins. So if you need to send off 3 requests simultaneously and then join the data together in one place, and then potentially make a third request based on the results of the first 2, PowerShell script, happy days. The on-premise version, if you went to your security team and said, hey, you code me a sort of piece of software where people can send random PowerShell scripts from the web to my agent that can do anything that PowerShell can do, which is pretty much anything at this point, they would say no, and they would say, please uninstall this straight away. So what we've done is we said we want to make sure that your PowerShell scripts are within the context of your existing security controls. And the way to do that is to make sure that they are already on disk, so that your antivirus software understands that. It will scan those PowerShell scripts when they're being accessed, and you can review those scripts. You can source control those scripts. You can do whatever you want to do to them. So yes, with the on-premise PowerShell plugin, you don't give it a script. You pick from a list of scripts that are available to the agent on disk. They don't have to be on the agent's box. You could have a share set up and put the scripts in there. The point is you have to designate a file path and say scripts from this folder specifically are going to be allowed. And there's even an option to say, and I want to make sure that they're signed as well. So if you're running it on a Windows agent, you can say, and they have to be signed scripts as well. So you can really lock them down to make sure that they are valid scripts. But that is the one sort of time where you might want to pre-configure something or manage something locally, as opposed to all the other plugins that you just put in some credentials and it works magically. Is you need to actually provision those scripts there. But as you mentioned, Adam, those scripts then can output whatever you want. They output PowerShell objects. Basically, they don't even have to output JSON. They output PowerShell objects, and then the plugin automatically converts that into data format we can understand. So if your PowerShell script outputs, a list of files or a list of health states or whatever else, you will see that appear in the product as a table with a list of health states in it. Then you can do whatever you want. So it's very powerful in that sense. But you do have to get those scripts in place already, and you can use whatever internal tools you already have to do that.
Okay. Is there anything, just while we've got this diagram up, just before we wrap up, any sort of like best practice you can recommend? Or, I mean, we sort of covered like start small, build up over time, don't go crazy and deploy 50 agents on day one.
Yeah.
It's probably worth as well calling out that like a common misconception is people think, well, this is just like a monitoring tool, right? I need to put an agent on every machine I want to be able to talk to. Yeah. These are effectively gateways into your networks.
Yeah, exactly. If you think of them more of gateways, I would be, unless you are literally just setting it up for like, I've got one thing on premise this old thing that I still have hanging around from 1994 that I need to get access to. In any other scenario, I would probably say you want to set up a shared piece of infrastructure that you can use to host the agent. So in the Windows case, that's a VM. In the case of the containerized version, that is going to be on my existing cluster or Swarm or whatever you're using, or in the case of the two cloud products, their offerings, I would dedicate a container instance there and say this is going to be the point of entry for this data center. And then you can send your traffic in from there. And you really only need to think about co-locating it on an app, either when the volume of traffic starts to get such that it's a problem, or there's just some sort of permissions or security concern where it's like, actually, we just don't allow shared systems. Like, in our data center internally, all the different servers can talk to each other. But if you're not running that kind of environment, if you're running a heavily regulated lockdown environment, that's probably not going to be the case, especially if you're having to use like management jump boxes and things like that. Then you're going to need to locate these things directly on servers. But you should always start with the simple, and then you only go up as your network requirements demand of you, basically. That's what I would say. If you want to flip back to the cloud product, the cloud UI a second, the other sort of tip is just to keep an eye, make it a sort of part of your ongoing maintenance schedule, just to keep an eye on this page, because it does have here those little version indicators, which will alert you automatically that there is a newer version of the agent available. We don't publish new versions of the agent that often, because if we're doing that, we're changing the actual agent behavior itself, and it really is just acting as a gateway. It's emulating our sort of our data source environment, basically in your environment rather than in the cloud. So we don't change that underlying infrastructure that much, but if we do, it means it's a performance of security or bug fix, basically. So it does benefit you to upgrade it. The upgrade process is super simple. If you're running a containerized version, you obviously just pull the latest version of the container. Happy days, done. Kept it up to the same config settings, same API key, and you're away. If you're running on Windows, the PowerShell installation script has an upgrade switch. You just point it at your agent instance. If there's only one on the box, it finds that one, and then it upgrades it. The agent itself is completely transient, apart from the API key that you give it when you set it up, basically to identify which agent it is. So we can throw it away and download all the plugin content and everything else again. They're not large, so it doesn't take very long at all. They are all, for the most part, bytes or kilobytes in size. So you don't really need to this is not one of those sort of like hand-grown, hand-spun server kind of things. This is just, I'll throw it away and get a new one. So keep an eye for that little update marker. It's one thing to sort of bear in mind. And then you can see the platform. When you first create an agent, it will have a blank name and host and version and platform column, because we don't know what it is yet. It hasn't dialed home. So you'll get an API key. You plug that into the agent software itself. And then the first time it connects up and does its handshake with SQUPCAST Cloud, it will then tell us these things. And, we're not doing anything with the host name. The host name is just there. We added that just so people could find their VM again, because we have a constant request of I've installed an agent somewhere, I can't find it, I've lost it. So that just became a way of making it easy for you to manage that. So obviously it may or may not be meaningful depending on what you've deployed it on. If it's an Azure container instance, you get a lovely name like that. But it might help you to figure out where it is. And then the platform will be derived automatically. So we know we're running on Linux or Windows. And then based on how you've assigned that agent to agent groups, they derive their platform. So you can see there below, we've got two agent groups that are Windows, because all of the agents in them are Windows only. So it naturally becomes Windows one. Linux is Linux for the third one. And then the fourth one is mixed, because it has a mix of agents assigned to it. If we took one of those two agents out, it would stop being mixed and immediately flip to whatever the platform is for the only one that's in there. And the product is perfectly fine with you making a agent group become mixed platform, as long as there's no plugins assigned to it already that are saying, sorry,
Yeah,
I'm not
we
actually
need Windows.
cross-platform
Yeah,
capable. You can't do that.
cool. I noticed there's sort of the health state icons as well over on the left.
Yeah.
That's just based on the agent calling home, and then the group one is just based on the sum of the agents within it, right?
Yeah, exactly. So it is possible sometimes to get some slightly confusing answers there. But that's just because, like you say, the agent health is based on, is this agent running and is it heart beating and talking to us? The agent groups is based on how many instances do I have right now. So you might have like one agent go red because we can't talk to it anymore, or go yellow if it's been a little while, it's missed its check-in by a minute or so, but we're just going to let by less than a minute, but it's missed it by a few seconds. We're going to let this thing, give it a grace period, but that's suspicious. The agent group will stay green if all of them are in. It goes yellow if one or more of the agents are not talking to it right now. And that might indicate there's some connectivity issues, because again, in this in this example here, the agent group at the bottom is yellow, but the agents are all green. Is that slide down? There you go.
Yeah.
So the agents are all green. What that means is that the connection to Squared Up is fine, but that agent group, one of those agents is having a problem talking into Azure. So we need to look at that and say, okay, well, what are those two agents? And if you mouse over the warning mark, it will actually tell you. It's not a very exciting tooltip, but it tells you how many are currently. There you go. So only one of those two agents is currently listening right now. So that might indicate there's some kind of connectivity problem. And we can go and check the logs on those agents. All the logging for the agent is inside the transient logs folder, and you get very detailed logging in there. So you can take those logs to support, and they'll analyze those for you and tell you what's going on. You can poke them yourself as well, just using a standard text editor. So feel free to have a look there if you want to try and resolve the issue yourself before reaching out to support. It's all in plain English, pretty much. But yeah, that gives you that health idea. So okay, as long as the agent group is not red, it can service traffic, and that's fine.
Mm-hmm.
If it goes red, it means that one of the agents all of the agents for that are currently offline.
Gotcha. So I guess just to sort of sum up then before we sort of finish, we've been building data center software for quite a long time now, and we still know what we're doing, right? And
yes.
You worked on Dashboard Server for many, many, many years before working on the Relay agent. So we understand our customers, we understand security concerns and the kind of things, there's a lot of sort of SCOM inspiration in some of the terminology that we've used, or at least some of the architecture we've used around groups full of agents and that kind of stuff. So it can, I'd hope that people watching this can take the fact that we can be trusted with putting some software into your data center. We have been doing it for a long time. And it's there to be as resilient, as redundant, as up and away as it needs to be for your use case. Yeah,
exactly. Yeah, I mean that point about sort of we've done this for a while. We've modeled it on SCOM. The other thing we modeled on SCOM is like the plugin, the data sources that we send down are on disk. They are there. So again, if your security team has concerns about this, like, well, hang on a minute, this Squared Up company can just send whatever traffic they like. They can't send whatever traffic they like. We can only send requests that the data sources themselves recognize. And again, your antivirus has access to all of that. It's not minified and obscured so that we protect the IP. It's there plain, just like it would be for SCOM, on disk, so that we can be scanned and verified and be like, yep, we are confident this is exactly what we expect it to be.
Nice. So. Okay, I'll go ahead and wrap us up. We're just running up to the end of the time. Thank you very much for joining, first of all, Matthew.
No worries.
Good deep dive, and questions, as always, can go through our support team if you're getting stuck sort of trying this out. So yeah, support@squaredup.com or docs.squaredup.com if you want to sort of check out the documentation specifically. But otherwise, community.squaredup.com, our community answers platform, is a great place to go and hang out and ask questions, whatever, that kind of stuff that people say about forum. It's a really good tech forum. There's lots of stuff in there, especially around our new cloud product. That section's growing really nicely. As always, if you have any ideas, if you're checking this out, there's a plugin missing that you want, feedback.squaredup.com is a great place for that. Yep. And I haven't set a challenge to win any Lego this week, but maybe if you count the number of times Matthew said on-prem and then email me at SQUPCAST@squaredup.com, I might send you a little prize.
Well, either that or it used to be send us a screenshot of it running on your home NAS.
Yes, fine. That's good. Yeah, from the Synology console specifically. Yeah.
Where's the weirdest place you can get the agent to run?
On a fridge, maybe. Let's try that. Docker on a fridge, anyone? Go
We've
for it.
had dashboards on a fridge before.
It's true. It's true.
So
cool. Well, I'll go ahead and wrap us up. We haven't finalized the topic for the next session yet. There's still just too many good ideas all fighting for the next few slots. So if you do normally subscribe to check out the next one, keep an eye on squaredup.com for updates and in your inbox. But yeah, thanks again, Matthew. We'll leave it there for today.
right, thanks, guys.
Thanks all.